Hello everyone, today I am going to explain this problem. As you all can see, this is the function which is given to us, that is y is equal to g of x, and we have to find f of y, that is the probability density function, probability distribution function, and the mean of y. Now here g of x is equal to 1 for x smaller than minus 1. Therefore, when x is smaller than minus 1, we have g of x is equal to 1. Between minus 1 to 1, that is between minus 1 to 1, x is equal to y, which is you can see in the graph. And for x greater than 1, we have a value of y, that is 0.5. So this is the graph of g of x. Now looking at the graph, we can see that we have two discontinuities, that is at 1 and at 0.5. When y is equal to y, or g of x is equal to 1, we have a discontinuity, and again at 0.5 we have discontinuity, and therefore at these 2 points we get impulses. Now it is given that x is uniform between minus 2 and 2, that is, it is a uniform function, and the height is 1/4. It is a uniform function. Now we have to calculate f of y. F of y, we have an impulse at y is equal to 1. When y is equal to 1, we have an impulse, that is a discontinuity, and therefore it is given by delta y minus 1, where y represents y is equal to 1, that is, it is used to represent that the impulse is present at y is equal to 1. And 1/4 is the area. Here the function runs from minus infinity to minus 1. The same function, when represented over here, f of x, we do not have minus infinity, that is, we have function only from minus 2 to minus 1, and therefore the area in this particular section, minus 2 to minus 1, is 1/4, and that is why we represent it as 1/4. The same is the case at y is equal to 0.5. y is equal to 0.5, we have an impulse. That is, if we come from infinity to 1, this area is represented here. However, the function is uniform only between 2 to 1, and therefore the area between 2 and 1 is quarter, or 1/4, which is represented as 1/4 delta y minus 0.5, which indicates that the impulse is present at y is equal to 0.5. And between minus 1 to 1, f of x is equal to g of x. f of y is equal to f of x, that is, they are equal, y is equal to x, and therefore we represent that as 1/4, which is the same as the f of x. F of y is the same as f of x, which is 1/4. Representing this here in the graph, we have from minus 1 to 1, we have a uniform function, and the height is 1/4, and at 0.5 and 0.1 we have impulses whose areas is 1/4. And to verify this, we can calculate the area of this function. Say minus 1 to 1, that is the gap of 2 into 1/4, we get 1/2. 1/2 plus the area of the two impulses, therefore the area under this graph is 1. 2 times 1 by 4th, that is 1 by 2 plus the area of this 1 by 2, that is equal to 1. Therefore we get this area as 1, and so it is verified. It can be represented as f of y is equal to 1 by 4 delta y minus 1 plus 1 by 4 delta y minus 1 plus a step function y plus 1 minus u of y minus 1 by 4. Now going further, this is the probability distribution function of y. We have seen the density function is present between -1 to 1. Now calculating the probability distribution function. Distribution function, we know that from -1 to 0.5 this is uniform, that is the slope is 1 by 4th, which is the height of the step function. Then we have discontinuity at 0.5, that is we have an impulse, and the step size is equal to the area under the impulse. Area under the impulse is 1 by 4 and the step size is hence 1 by 4. Again we have a slope between 0.5 to 1, that is between 0.5 to 1 we have a uniform function. We have a ramp over here, and from 1 we have a discontinuity here, that is we have an impulse function, and in this particular probability density function we have an impulse, and area of the impulse is 1 by 4, then hence the step size over here is 1 by 4. So this becomes our probability distribution function. As we can see that the slope is 1 by 4th from -1 to 5, and calculating y by x, that is the slope is equal to 1 by 4th, we have the value of x, say 1, and this is the value of x, that is equal to 0.5 plus 1, 1.5. This is the base of, and therefore we have y, that is equal to 3 by 8. Therefore this value which we get is 3 by 8. Again the step size is equal to 1 by 4 at 0.5. we have step size, which is the area of the impulse. Same, the area of the impulse, add 1, this is the step size, and slope between 0.5 to 1, that is 0.5 to 1, we have a slope of 1 by 4. Representing the same, we get 1 for y greater than or equal to 1, that is 1. We have 0 for y smaller than -1, and we have this equation, that is from -1 to 0.5. From -1 to 0.5 we have this equation y by 4 plus 1 by 4, which is this probability density distribution probability distribution function, which is this equation of this line, which is this, and y by 4 plus 1 by 2, which is the equation of this line, and that is between 0.5 to 1. So here we get the probability distribution function of f of y. Now in order to calculate the mean, we have the formula mean of y is equal to area A minus area B. This area minus this area, we get mean of y. Here I have calculated the mean of y, that is the area A minus area B. Area A is this, and this is the area B, and on subtracting both the areas we get 3 by 8 as the mean. This is graphically. However, by definition, that is integration minus infinity to infinity y f of I dy, and integrating the f of y function, we get this delta function y is equal to 1. Integration gives y is equal to 1. Putting that 1 into this y, we get 1 by 4. Similarly here we get 0.5 by 4, and this particular function, that is the step function, is even function. However, we have multiplied that even function with y, and y is odd. This makes this function as an odd function. An odd function from minus infinity to infinity integration is 0, and hence we have discarded this. Adding both, we get the area, the mean as 3 by 8, and we can see that graphically the result matches with the formula, and so this is the mean of y. Thank you.